taking the integral from 0 to infinity and finding out the power. So you evaluate the integral and then you get a squared. Once you evaluate the integral, you got a squared. After getting the a squared, you let the, find the average power, you need to let the limit t go to infinity. Okay. So if we get a power, an answer that's finite, that means this is a power signal. Any question?
Sir.
Yes.
Can you go to the about the power signal again, sir? Because of Wi-Fi is not good, not stable, sir.
Huh?
Go up some more, sir. Okay, stop here. Can you explain about no, down, sir. Down some more, sir. Down some more. Starting from the example there, sir.
Okay. Okay, what do you want me to explain?
I need to explain how the power work for the delivery, sir.
Beg pardon?
I don't understand what's the method of power.
Power, did you go through the previous lecture?
Yes, sir.
Previous lecture, and then I define how to find the power here using this formula.
Yes, sir.
I tried. Yeah, so that's the same formula I'm using right now. Okay, to evaluate the power. It's the same formula. So in this formula, you can either go from, so you need to look at your, every time before you come here, you need to go through your lecture. Okay, I'm applying this to find the power. You can apply this formula to find the power.
Okay, sir.
The lower limit, you can either integrate from 0 to t or minus t over 2 to t over 2.
Okay, sir.
Any other question?
No, sir.
So I'm applying this formula here to this signal. The signal is defined. The signal is defined. This is the area. We're finding the area under the curve. I'm taking the average of it. Divide by the period. Apparently this, okay, any other question? Let's move on to the next one. Next example is, say you have a signal like this. You have seen this signal before. Okay. This is a sinusoidal signal. We have seen this signal before, and then we used to call this xt. Xt as an amplitude, A, cosine, omega t frequency times time plus the phase shift. Okay, now we want to find the energy in the signal. So in order to find the energy in the signal, we apply this formula. Energy minus infinity to positive infinity. Okay, the reason why when you square the signal, without squaring the signal, you won't be able to integrate this, because if you integrate this as sinusoidal, the energy will be zero over a period. So that's why squaring this is basically rectifying the signal, right? It rectifies the signal. You're not only rectifying it, and then you're also squaring it, when you square it, this is a rectification. And then when you square it, it becomes higher. I don't know how high this is, but just to give you an idea what this formula is doing. So it's squaring it and then it integrating it over a period, and then you will take the it's just integrating this. It's not just integrating this from minus infinity to positive infinity. Okay, not period, from minus infinity to positive infinity. Cosine omega t plus theta squared. So that's going to be minus infinity, positive infinity, cosine squared omega t plus theta. So how to integrate this? You can use a U substitution. You can use U substitution. There can be other ways to integrate. You can use U substitution. U substitution, let U is omega t plus theta. Let U to be this. Let U to be omega t plus theta. Then therefore what's going to be du? Du dt is du dt is omega, right? Theta is a constant, so it's 0. So therefore du is just omega dt. Everybody follow? Everybody is still
Yes, sir.
Yes, sir.
Yes, sir.
connected? Oh, good.
Yes, sir.
Okay, now we know. So please note the upper limit and the lower limit. And because the upper limit is minus infinity, and the lower limit is minus infinity, the upper limit is infinity. We can always use because now we are changing variable to u, but this infinity applies for dt, right? Time. We can change it to our domain because now we already changed to u and du. So we want to find out what will be the limit. Okay, when t goes to minus infinity, what is u? Okay, since you know u is omega t plus theta, right? When t goes to infinity, what happens to u? Okay, t also goes to infinity. When t goes to infinity, and you have t here, t goes to infinity. If t goes to infinity, definitely omega t is going to go to infinity, right? So omega is constant. Omega is a constant frequency. So this is also constant. So when t goes to infinity, omega t also goes to infinity. So this is minus infinity. So similarly, if t goes to positive infinity, u is going to positive infinity. Okay. Any question on that?
No, sir.
No.
Okay. Now I can go and so once I establish this change of variables, I don't have to convert this back to time to solve it. So now your E becomes a squared. A is missing here for some reason. I'm sorry, I missed the A. Okay, let me put the a squared outside here. It should be a. Minus infinity to positive infinity, then cosine squared u du. Omega du. A squared over omega squared cosine squared u du. To integrate this, we have to use the trig identity to convert cosine squared u to 1 plus using the trig identity. Do you remember the trig identity? Cosine squared u becomes 1 plus cosine 2u divided by 2. Du. We can move the 2 over to the outside because it's a constant. Now go ahead and integrate this.
Sir, the omega, is it omega square or omega only?
Sorry, just omega.
Okay, sir.
Thank you for the observation. Sorry about that. Thank you very much, Jintek.
Welcome, sir.
So any other things? So therefore, if you integrate, it's going to be u, and then 1 becomes u, right? And then the integral of sine cosine 2u is plus sine 2u, and then divided by 2 minus infinity to infinity. 2 times infinity, also infinity, right? And then minus u now becomes the lower limit minus infinity, again plus sine minus infinity. Any question? This one, divide by 2. Okay. Divided by 2. So let's evaluate. Any question?
No, sir.
No, sir.
Infinity. What is sine infinity? Okay, sine infinity. This is sine infinity. Sine infinity. Sine is going to keep on, and time goes to, as u goes to infinity. Let's say this is u, right? Then this is sine going to oscillate from -1 to -1 to +1 as u goes to infinity, right or not? It's a bounded signal. It's not going to grow, right?
Yes.
So this is going to be like plus or minus 1 maximum, right? So overall, I can tell like that this is overall result here is dominated by this infinity. This infinity dominated by this. Because sine only oscillates from -1 to +1. You guys follow the logic?
Yes.
So similarly, on this side also is going to be minus infinity. The sign is not going to affect the result because it's going to just oscillate from -1 to +1. It's a bounded signal. Infinity minus infinity becomes 2 infinity, and finally it will reduce to infinity, right? And therefore this is going to be infinity. So energy signal is infinity. So not an energy signal. Okay. So if it's not an energy signal, let us check and see if it's a power signal. Any questions so far in this? These are all integrals. I know you guys can go home and check this out. If you still don't understand any steps, you can ask me. Okay. Now I'm just doing all these things in detail to show you what this formula is doing. Okay. So now let's calculate the power. It's not energy signal. Is it a power signal? Let's find out. Using that formula 1 over t, 0 to t. So if you note inside here, like if you look at this part of the integral, this part of the integral is kind of same, isn't it? Same as before, isn't it? Integral.
Yes.
The only difference between this, we have an additional thing here. This is a different, energy doesn't have this, and energy goes from minus infinity to positive infinity. Okay. So we don't have to integrate again, only the limits and the division by t. That's the only difference. We don't have to integrate all over again. We can use the previous results. We can use the previous integration. But now to begin with, we'll just show that 1 over t 0 to t a the whole thing squared, the same as before. Same as before. The only difference now we're going to get a squared over t. 0 to t so previously, now we have a squared over t. Previously we had a squared over omega. Sorry, previously we just had a squared. Okay, previously we had just had a squared. And now we have a squared over t. T was already there. For the part of the integral, for the integration part, it's still the same, isn't it? The integration part, if you look here, we just have need to put this, and if you don't want to integrate again, you can just use this result to previously we had we also have, okay, sorry, we still have the two omega, am I right? But in addition to that, we have also have a t, isn't it? In addition to that, we have a t. I don't know if I'm maybe doing it, maybe there'll be small changes, but it is not going to make much difference in the final result. Now is this going from 0 to t. Now you go ahead and substitute the upper and lower limit. Upper limit is t plus sine 2t divided by 2 minus lower limit 0 minus u0 sine 0 0 Okay, now this is the power signal. Okay, the power is limit, the average power is limit as t goes to infinity. Okay, when t goes to infinity, I've already told you that it is not going to, let me rewrite this. Okay, limit as t goes to infinity, when there's no t dependency, it's just going to be 1 here, right? And t is going to limit 1 as t goes to infinity is just 1. So on the other part is 0. We already analyzed this. As t goes to infinity, this is going to be just a plus minus 1. But this will go to infinity. Okay? So division by infinity, plus minus 1 division by infinity. So this is going to be 0. That's 0. So finally, your average power is a squared over 2 omega. There's omega dependency. I don't know if there's a mistake or not, but all you need to conclude here, yes, this is a power signal. If anybody see any error, you can let me know. So this is a power signal. We will be doing more examples. Any question?
So what is the condition to be recognized as power signal?
Okay, the condition is, good question. Condition means same as like what energy thing. Power has to be between infinity and 0. A finite must be finite value. So this is a power signal. All right.
Okay.
Okay. Okay, guys, still we are doing the introduction part. I'm going to just doing some very basic things. And these basic things are very important when you go in the midterm, especially these things are very important. Energy, periodic signals, and basic understanding of how to sketch some signals. So I'm just going through going to go through some background here. Okay. So next what I'm going to do is I'm going to go through all the basic signals. Basic signals. Time inversion. Let me next talk about transformation of time variable. Let's say you have a signal like this. So let's say this is xt. Xt is a ut or something, you know, for example. Okay, sorry, positive ut. Time inversion. If I make this negative, u minus t is going to give you a time inversion. Signal is going to go this way. Okay, so in this case, u minus t in this case ut one for t greater than 0. Looks too small out there. Let me ut is equals to 1 for t greater equal to 0, but 0 for t less than 0. But in this case, u minus t is the other way around. It's going to be 0, it's going to be 1 for t less or equals to 0, but it's going to be 0 for t greater than 0. So this is time inversion. This is called transformation put it here. So next property is called time scaling. Okay. Okay, another example of time inversion. XT Are you guys with me? Are you guys
Yes, sir.
still online?
Yes, sir.
Yes, sir.
Yes, sir.
Good.
Yes, sir.
Is anybody drinking tea? I can smell it.
Yes.
G, drinking tea? Okay.
No, sir.
He's drinking beer, sir.
Drinking beer,
No, sir.
uh,
Wait, get that.
you can drink whatever you like because it's your house. You're in your house, right?
Yes, sir. Hey, get that. Don't say that.
Okay, settle down. Later on, you guys can fight. You know, I can be a referee after the class. So let's say this is a signal xt given. So how does the x minus t looks like? Okay, this is xt. And this is x minus t on the left side. So we can see what time inversion does. They all have application when you go to signal and systems, time inversion. Then we look at time scaling. Time scaling x to t. Okay, x to t. Now what happens is when you do it, you're going to divide everything by 2. So what happens? 4 divided by 2. So this times 2 here means divide by 2 there. Okay. Uh, Hi, can you hear me?
Yes, sir.
Yes, sir.
Yes,
Then,
sir.
Of course, sir.
Yes,
okay, then
sir.
Ilashini can't hear me. Ilashini,
Yes, sir.
maybe you have,
No, sir.
you can hear. Everybody can hear me except one or two students got disconnected. Okay, let's go back. So time scaling. Okay, that's a time scaling when it's x to t. X t over 2 x t over 2 is going to be widen the time span, like 4, right? So it's going to be like 4 times 2, everywhere times 2. So your 4 becomes 2. Sorry, your 4 becomes 8. Okay, these are the few examples, and just to give you guys some idea. Then what do we have? We also have time shifting. When we have a time shift, for example, xt minus 2. So you're going to shift, that means xt minus 2 is same as saying that you're moving the signal by 2 to the right, So you move the signal. So this is xt minus 2. Are you guys still connected?
Yes, sir.
So what
Yes,
about
sir.
Ilashini? Are you in?
Yes.
Huh?
Yeah, we are in, sir.
Okay, good. Plus 2. class 2, what you do is you go back to the original signal. Signal was here, right? Originally the signal was here, isn't it? So class 2, what are you going to do? You are moving to the left. I mean, when you solve for t going to be -2, so you're going to move to the left. So now you're at -2. Forgot to put the minus. Okay. Any question?
No, sir.
No, sir.
No, sir.
So this is the time shifting. Forgot to say what this is. It's called time shifting. I don't know why one student got disconnected. Is everybody in here? Let me
Yes,
go
sir.
and check it.
Yes,
Sir.
sir.
Everybody still not admitted. Everybody's admitted, right?
Yes.
Yes, sir.
Okay, now can you, how can I, this is a signal that's defined to be xt two. For t, when t is between 0 I can realize the signal using two different step functions. One step function will start at 3. With the amplitude 2. So this is amplitude 2, and then it's starting at 3. So when it's starting at 3, inside the parentheses, it should be t minus 3. The other signal is starting at 5. Same thing, amplitude is 2, but it starts at 5. So if you subtract this minus this, will give you this. Maybe I didn't, let me align this properly here so that you will see this cap, right? Okay, this minus. Okay, 2 minus, so you can drop a line here and then you can see 3. Therefore, xt okay. Because later
Okay,
on it will be helpful. There are also notes on other things that you might want to go. Okay, like maybe I want to move to the digital part, more on the discrete time signals. You also can go ahead and this semester, because we are doing things online, so I'm trying to keep the important things. Yeah, but there are a lot more things that you can look at the older notes, which you can go through by yourself. Okay. If I look at the older notes, into the previous one, like intro to signal of the previous semesters, it has more notes. If you want, you can go and see. But this semester, I'm kind of only focusing on the important ones. Those who want to have more idea can read more. See all the systems, all these are easy. You can just read them yourself. But I'm going to just focus on the important ones. Maybe I'll go through these things. Are you guys still in?
Yes, sir.
Okay. Now I want to go through some of the digital, not digital, discrete time signals, discrete time. It's very important to understand this discrete time signal mathematics very well, because later on it will be helpful when you do discrete time convolution. For discrete time, we use x of n. X as a function of n. And n is the discrete time. Somebody sending me a WhatsApp message. Let me check this out. Somebody is still struggling from outside, or it's from somewhere else.
I think no, sir.
All clear, sir.
Okay. Signal at time at -1 is 0. Signal at not -1. Signal at -2 is 0. -1 is 0. Signal at 0 is also 0. Signal at 1 is 1. Signal at 2, signal level at 2 is 2. Signal level at 3 and 4, 3. Okay, and then signal level at 5 is 0. Okay. So this is a finite number of signals. It starts from -1 and then it ends at 6. Okay, so this is x of n. Now, how do you sketch x? Sketch x n minus 2. So the whole thing is going to be moved to the left or right by 2.
To the right.
Okay, good. Okay, next. x2n. Maybe I'm not going to do this because I want to do this. X minus n. X minus n. You just take the n down here for reference. So what are you going to do? X minus n. plus 4 becomes minus 4, plus 3 becomes minus 3. Why my hands are so shaky? Maybe I've done something wrong. Plus 1 becomes minus 1. And then what? The rest is
all 0.
yeah, you go back to the original signal and then you see all these guys here, all these zeros, they're on the left. Now becomes minus 1 becomes plus 1. The 0 shift to plus 1 and plus 2.
Sir,
Left to the left.
shift to
Now
the left, sir.
So the
Because
two,
of plus 2.
now what is the 2 is going to do? What is the 2 going to do?
Move to the left, sir, by twice.
Why left?
Plus 2, sir. Plus 2, that's why.
Yeah, that's why this is kind of tricky. See, minus n plus 2 is 0. So minus n is minus 2. So n is 2. So that means you have to add 2. Am I right?
Right, sir.
Did I? Okay, did I do? Let me see something. Okay. Can I check something very quickly, please? Okay, hold on a second. Minus n, okay.
Because minus n is only for flip. Plus 2 is for shift to the left.
Okay, let me. Okay, G, let me do this again. I think we have made a mistake here. We have made a mistake here. Let me go and fix this first. This is x of n, right? Okay.
Okay,
Okay,
sir.
this is okay. This is x of n, and then let's make minus n first. If you look at this, let me copy this over. Put it here, around here for reference. If you look, if I flip around the 0, I don't know what I was doing. Sorry about this. Okay, all this. I don't know why no one was objecting. Okay, when you flip around here, this 0, what happens is -1, -2, -1 and 2 becomes +1 and 2. Okay, but here on this side, +6 becomes -6, correct? So this is not done yet. So we look -5, -6. Now this is right. Maybe I shouldn't put this arrow here. flip around here. Okay, now you guys, can you follow this?
Yes, sir.
Yes,
Huh?
sir.
Do you agree with this
Yes,
answer?
sir. Yes,
When
yes.
you flip
Agree, sir.
around, whatever on the right goes to the left. Whatever on the left goes to the right. And then not only that, they change the sign. Like -2, -1 becomes +1, +2. Okay. So that part agree or not?
Okay, sir.
Agree, sir.
Okay, let's start over this. The more mistake I make, the more problem I have when later when I go and edit this. But it's okay, no, discussion is good, mistake is good. So when I make mistake, you get some time to breathe, right?
Yeah, sir.
So now what we want to do is we want to do that x minus n plus 2. That's why I said this is kind of tricky. We already flipped this. Now we want to shift that +2, but it's easy to imagine that you're going to make, you might be thinking minus n is equal to -2, right or not? But
Yes.
n is 2. So you're going to add 2. So what we're going to do is we're going to add 2 plus 2 plus 2 all the way up to here plus 2. When you do that, what you will get, maybe I put my little work here so that you can see. So all of them going to get shifted to the right. If you're still confused, that's fine. I'll do in another way, you'll see. So -6 plus 2 is -4. -4 minus 0, -1, -2, -3, -4. So -2 plus 2 -1, and then this gets shifted over here. So all I'm doing, I'm just adding 2. to get this, which is okay. You guys are still around?
Yes, sir.
Okay, now let me do it another way. In another way, what you do first is you can do this. Okay. Oh, alternative way. Let's do this. Okay. Okay, let me bring the original signal for reference. Okay, bear with me. Maybe this is the last example that we're going to do. Okay, this is the original signal. So we wanted to find, we wanted x minus n plus, plus 2, right? Okay, what you can do first, you can do this first. Try doing this first, x n plus 2 first. When you do this, like n plus 2 is 0, then n is minus 2. Like what G said, now we can move it to the left. So now you can move everything to the left. Then that means you just minus 2 each one of them. Like I'm going to minus 2. Minus 2. In that case, you're going to get so minus 2 is minus 4, right? So your first point is going to be like minus 4. Your 1 okay, you guys follow so far?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, just 5 more minutes, maybe 1 more minute. So this is x n plus 2. Now from here, if you want to do let's say if you want to do yes, somebody turn on the mic. Okay, now if you want to do x minus n plus 2, all you have to do is flip around this, right? Flip,
Yes, sir.
flip. So when you flip, what do you get? You get okay. All right, so this is another way. I just put number 2, way number 2, and the previous one was way number 1. And both of them are the same, isn't it? Can you see?
Yes, sir.
So you can pick, maybe the second way is more easier, right, to do. Like maybe you want to shift first, and then you want to shift it first, and then you flip it when the time is inverted. Okay, guys, so do you all follow?
Yes.
Maybe
Yes.
tomorrow morning, what I'm going to do?
Yes, sir.
Okay. Is everybody? Some students had questions about the assignment. For the assignment part, I'll do more examples. If you ask me how to do the assignment, I might not be able to do that. If it's really simple, I'm going to do more examples. If it's really complicated, you can ask me. Very simple, straightforward ones. You should think about it and do it.